Hello students, welcome to my channel MS Maths. So today we will discuss something about arithmetic of integers. That means chapter number 3. And in this chapter whatever examples are there, then we will discuss about that and we will try to solve the sums of the exercise 3.1 also. So it is starting of chapter 3 and the name of the chapter is arithmetic of integers. So here something is, this chapter is related to actually natural numbers. Natural numbers, first of all, what happens, we all of you know that natural number starts from 1, then 2, then 3, that all of you know. It goes on like that, 1 2 3 4 5 6, this way, or we can write this way also, 1 2 3 4 5 and so on. So this way, without, instead of putting comma, we can write this way. I hope you understand. 1 is smaller than 2, 2 is smaller than 3, 3 is smaller than 4, or we can say 2 is greater than 1, 3 is greater than 2, 4 is greater than 3 and 5 is greater than 4. This way we can go on reading or we can go on writing also. So any natural numbers, whether it starts from 1, whether it starts from 10, so it goes on increasing, that all of we know. So any natural number, if it starts from 10, so next number will be 11, then next number will be 12. That means what? 10, 10 plus 1, 10 plus 2. So it goes on like that. So this is a common sense. This is common to all of us. But on the basis of this, we are going to learn something about the addition of some special type of natural numbers. Special type of natural numbers. Remember that here, in this chapter, we will do only of natural numbers, not integers. Only we will be related with natural numbers. So here it is written in the page number 98, the set of natural numbers. So that is just written, whatever I have written here, it is written. Using symbols, we express them as 1, 2, like this, as the natural numbers are represented by capital letter of N. That we all of us know that natural number is represented by the capital number of N. Sorry, capital alphabet N, capital letter of N. That all of us know. So what is important here, how the numbers, natural numbers starts and ends, what is the style, what is the nature of natural numbers. In a series, if we write a natural numbers, so it goes on increasing. It goes on increasing. Suppose 1 plus 2 plus 3 plus 4. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Then 1 plus 2 plus 3 plus 4 plus 5. Then 15. So 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So till here it is 10. Then 10 plus 5, 15. Then it is 6. So 15 plus 6, 21. So it goes on like that. If it is a huge number, suppose like this, we are going on writing 100 times. So 1 to 100. 1 plus 2 plus 3 plus till 100. We were supposed to add all the numbers, all the natural numbers from 1 to 100. So it is not possible to, it is possible, but it will take so much time to add one by one. If it is 1000, if it is 1 lakh, so there must be some special technique to add different type of natural numbers and different nature of natural numbers. Suppose 1 square plus 2 square plus 3 square, it goes on like this, 100 square suppose. So how to add this type of numbers, natural numbers? Especially remember the word natural number. Suppose it is 3 square plus 5 square, 7 square. This is a style of natural number. Two different. 3 plus 2 5, 5 plus 2 7, this way. 1 square, so 1 cube plus 3 cube plus 5 cube. So these are some nature of way of writing some natural numbers. So how to add this type of natural numbers, that is what we are going to learn here. We are going to learn this type of addition of different types of natural numbers. Okay. Now 3.2, that is page number 99. So there is one term written, ordering property. So this is a term, we just remember the word, the term, that what is the meaning of this ordering property. So what I have told already in the previous this here I have shown this is done by one insect. Okay, so no need to see that. 1 plus 2 plus 3 plus 4. Next will be, so here there is 1 2 3 4 4 terms. 4 terms, we have added 4 terms. 4 terms. Next 5 terms. Next 6 terms. That is called order. First is 4 terms. Next 4 plus 1 terms. Next 4 plus 2 terms. Like that. Okay. If we use 4 only, then 4 next number will come. If we 1 2 3 4, next number will come 5. That means how many terms? 5 terms. Next number will come 6. How many terms? 6. 4 plus 1, 4 plus 2. So this is called ordering property. Ordering property. It is written here. So this is nothing else. So this you don't have to go too deeply. So just we have to understand that number one, this 3.1 exercise, 3.1 and all everything whatever related to exercise 3.1 just related to natural number, and the natural number will be always in order. Difference between the natural number, first two natural number, second two natural number, third two natural number, so this will be always same. That should, there will be some always order. So what I have told you here, 3 5 7 maybe square but difference is same. 3 to 5, 5 plus 2 7, 7 plus 2 9, this way. 1 plus 2 3, 3 plus 2 5. So this is order. That is what it's written here, ordering property. So on the basis of ordering property, the addition, the sum of the natural numbers, how can we add? That method is called method of induction. It can be easily understood that there is no largest or greatest element in natural number. That is, no matter how large a natural number is considered, another natural number can be found next to it, which is greater than the number considered. So whatever number, if we start from 9, suppose natural number we are starting from 9. So next number we can understand, that is 9 plus 1. Next will be, this way it will go on. So suppose we have to start natural number from 100. So next will be 101. If we want to start natural number from 500, so next will be 501. If it is, that means if symbolically if we write, if it is x, so next will be x plus 1. We don't know what is x, but x is a natural number. X is a natural number. If it is n, next will be n plus 1, next will be n plus 2, this way. This way. If it is p, next will be p plus 1, because natural number, 1 by 1, 1 increasing. So that is ordering. property. Uh, so here we have to remember some special term. Special term means when we are given some sums to add in different order, then how will you prove or how will you add, how will you show that that method is called method of induction. We will try to solve all those mathematical induction with the help of some terms. Suppose first one is n, second will be n plus 1, first one is k, then next will be k plus 1, this way. This way we will take a term. Here in this mathematical induction, we will use the term k and k plus 1. We will not use n and n plus 1. So how will you use? That is what we understand. So look here. Here it is the number 1. 1 belongs to n. It means 1 is a natural number which belongs to natural number. So 1 is natural number. So 1 is natural number. Next, suppose k is also natural number. We don't know what is k. Among the natural number, k is something. K is some number. Whatever, maybe 100, maybe 1000, whatever it is. But k also is natural number. So k plus 1 also a natural number. If k is a natural number or k belongs to natural number, then k plus 1 also belongs to natural number. It means if 9 belongs to natural number, then 9 plus 1 also belongs to natural number. I hope you understand this. So in place of 9, k plus 1. So what we have to do, anything. Suppose here, what is written? Look here, 1 belongs to n. Next, 1 plus 1, whatever it is. 1 plus 1, that is what? 2. 2 also belongs to natural number. Next, given 2 belongs to n, that means 2 is a natural number. Next, 2 plus 1, that is 3 also belongs to natural number. Next, 3 is a natural number. Next, 3 plus 1 also, that means 4 belongs to natural number, and so on. And so on means etc. It goes on like that. I hope you understand. So this is 1, 2, 3, P, Q, K. K is a natural number. Like this, 3 is a natural number. So K plus 1 also belongs to natural number, because K, we don't know what is K. So K plus 1, we cannot get the answer. We cannot add it. 3 is a number, direct number. So 3 plus 1, 4 we can write. But K plus 1 we cannot write. So we will keep as it is, as this K plus 1 only. Okay. So main part, what I want to say you, that whenever we do any addition of natural number, any type of, any style, any type of natural numbers, then first we have to see that n equals to 1, then n equals to k, then n equals to k plus 1. It means in a series of natural number, if there are 1 term, that means n equals to 1. If there are 5 terms, so n equals to 5. If there are k terms, that means n equals to k. If there are 6 terms, then n equals to k plus 5. The sum of, let me write, sum of 6 natural numbers. Then sum of 6 plus 1, that means what? 7 natural numbers. So in place of 6, if we think k, then in place of 7, we will write k plus 1. So sum of 6 natural number will be natural number. Sum of 6 plus 1 means 7 natural number, also natural numbers. So this way, n means number. Number of terms, n means. So number of term 1, that means n equals to 1. Number of terms k. How many terms are there? 7 terms. 1 plus 2 plus 3 plus 4 plus 6 plus 7. So n equals to 7. 8 terms. N equals to 7 plus 1. This way. So we have to prove, we have to show n 1 term, k terms and k plus 1. Then if all are true for natural number, sum of n means 1 term, sum of k terms, sum of k plus 1 term. In another word, sum of 1 term, sum of 5 terms, sum of 6 terms will be a natural number always. So that is common sense actually. The sum of any natural number will be always natural number, but we have to show it. How to show? So we will show these 3 points. Remember these 3 points. Okay. Here one more you have to learn. Statement of n. Statement of n. Statement of n means sum of n numbers. Statement of n we will read as n. Look here. I will show you one example. 1 plus 2 plus 3. That means we will write as 3. 1 plus 2 plus 3 plus 4. So as 4. 1 plus 2 plus 3 plus 10. Then as 10. As 10. 1 plus 2 plus 3 plus 10 plus k. Then as k. As k. Say 1 to k how many terms? K terms. 1 to 10 how many terms? 10 terms. 1 to k. So here I have written k. So next will be k plus 1. So then as k plus 1. Sum of k plus 1 terms. That is what we have to show. K and k plus 1. K and k plus 1. If they are up to k terms, sum is a natural number. Up to k plus 1 also, k plus 1 term also sum the natural number. I repeat, up to 1 to 7, if we add whatever sum, whatever addition we will get, that is natural number. What I have told, 1 to 7. So next 1 to 8 also, the sum will be natural number. So in place of 7 and 8, I will read now k and k plus 1 or 7 and 7 plus 1. Up to 7 terms, up to 8 terms, up to 7 terms, up to 7 plus 1 terms, up to k terms, up to k plus 1 terms. So k plus 1. 1 means 1, first term. So this is what we have to show. As n. Statement of n, we will simply, shortly we will say as n. So there is example. Once we do this example, then you will, I hope, understand. So here proposition 3.2 method of mathematical induction. This is they are given in the book. Page number 100. In the page number 100, this whatever I just now I have given the points, that is what given. Now let Sn be a statement made for any natural number n such that number 1, S1 is true, that is Sn is true for n equals to 1. Number 1, S1 is true, that is Sn is also, n is true, also no need, Sn is true for n equals to 1. If S1 is true, that is Sn is true for n equals to 1. Sn means number of terms. First, n equals to 1 means first term. N equal to 1 means one term. So number 2, Sk is true, then Sk plus 1 is also true, that is Sn is true for n equals to k, and it is also true for n equals to k plus 1. So this one, and this one, these 3 points are required. These 3 points, n equals to 1, Sn is true, sum of natural number is true. What is true? True is that the sum of this natural number is natural number. Sk is also true. What is true? True is that the sum of k terms is also natural number. Sn for n k plus 1 is also true. What is true? That the sum of k plus 1 term also natural number. That is what we have to show. So here example number 3.2.1, when we do, then you will understand. When we do example 3.2.1, yes, then you will understand what is the fact. So what I have told, for n equals to 1, n equals to k, n equals to k plus 1, S1, Sk, Sk plus 1, all should be true. True. What is the true? What is true? That whatever we get, that belongs to natural number. Okay. This is the example. What is written in the example? 1 plus 2 plus 3 and n into n plus 1 by 2. What is the meaning? 1 plus 2 plus 3 plus 4 plus like this going on till n. If we want to add all the numbers, this formula can be used. Look here. Suppose there is written 1 plus 2 plus 3 plus 4. So what is the sum of these numbers? How many terms? 4. So 4 into 4 plus 1 by 2. Formula. How many terms? 4. So 4 into 4 plus 1 by 2. So 2 to the 4, 4 plus 1, 5, 5 into 2, 10. If we add 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So by applying this formula, we can add any serial numbers of natural number. Serially, in a sequence, it must be there, one after another, not jumping. If it is 1, 3, 5, no, it cannot be applied like this. So by first sum of first term, sum of k terms, and sum of k plus 1 also, if we add, this formula can be applied. That is what we have to show. Using the method of induction, show that for all n belongs to n, for all n belongs to n, 1 plus 2 plus 3 equals to n into n plus 1 by, this is left hand side, this is right hand side. We have to show. What we will show? In place of n, we will put 1 first. Secondly, we will put in place of n k, and thirdly, we will put in place of n k plus 1. K plus 1. After that, if both left hand side, right hand side, by putting n equals to 1, if left hand side RHS equal, by putting n equals to k, means value of n if we put k, in place of n if we put k, left hand side RHS if we get equal, in place of n if we put k plus 1, then also if we get LHS and RHS equal, then it is okay, it is proved. Then 1 plus 2 plus 3 plus till n equals to n into n plus 1 by 2. If it is 1 plus 2 plus 3 till 10, then what is the sum? 10 into 10 plus 1 by 2. 2 5 is 10, 10 plus 1 11, 11 into 5 is 55. So this way you can find out the addition of any natural number by using this formula. I hope you understand. But here we have to show with the help of mathematical induction. Mathematical induction. What are the statements we have to write? Because this type of sums will come in exam. The statements step by step you have to use properly, then only you will get full marks. First of all, whatever term is given, that you have solution. Whatever term is given, that you have to take left first. Sn equals to whatever term is given, we will write here. whatever it is given in the question. Now for n equals to 1, in place of n we will put 1. N equals to 1 means first term. First term. That means S1. N equals to 1 means S1. S1 means sum of first term, one term. One term means first term only. If it is 3S3, that is 1 plus 2 plus 3. If it is Sn, 1 plus 3 plus 2 plus 3 plus till n. I hope you understand. So n equals to 1. Now we will see left hand side. Left hand side, first term is 1 only. Nothing to do. Right hand side. First term is 1. So we have written LHS equal to 1. Now we will go to right hand side. Right hand side. Right hand side. N into n plus 1 by 2. So we have taken n equals to 1. So in place of n we will put 1. 1 plus 1, 2. 1 into 1 plus 1 is 2 by 2. 2, 2 cancel. What? 1. So LHS is 1. RS is also 1. Therefore, LHS equal to RS. So whatever I have written, you have to write that as it is like that. So we have to write now that S1 is true. S1 is true. What I have told, for n equals to 1 means first term we will take LHS. If it needs, sometimes it may need any calculation, so we will take one calculation, whatever we get, here we get. After equation, whatever there, that is in place of n1, n equals to 1 we will put. Now n equals to 1 finished. Now n equals to k. Now you have to use some sentence. Let us assume that, look here what I am writing. Let us assume that sk is equal to n equals to 1 plus 2 plus 3 n. Sk 1 plus 2 plus 3 plus plus k. Sn, here n. Here also n into n plus 1 by 2. So in place of n now I have written k. So here it is k. After equal sign also k into k plus 1 by 2. I hope you understand. Let us assume that sk is equal to this is also true. Also true. Or if it is, then we have to write b, not is, okay. So the b true for k is equal to 2. Sorry, n equals to k. In place of n we have written k now. In place of n we have written k now. So this is assumed. N equals to k is true. We have taken let. We have assumed that by putting n equals to k also sk will be true. What is the true? That it will be a natural number. So that k, n equals to k, we don't have to prove. We will prove n equals to k plus 1 actually true or not. Actually n equals to k plus 1 will be true or not. Now, so to prove now, what to prove? To prove that s k plus 1. Look here. S k is 1 to k. S k plus 1, how can we write? 1 plus 2 plus 3 plus k, then k plus 1. When sk, last term is k. When sk plus 1, then last term will be k plus 1. Look here. 1 plus 2 plus 3 plus 4 plus 5. It is called S5. S5 is 1 to 5. S6 will be 1 plus till 5, then 6 also. 5, then 5 plus 1. S5, 5, S6, 5 and 5 plus 1. Sk till k, Sk plus 1. So after k, 1 we have to write more. If it is 5, it will be 5 plus 1. If it is 10 terms, next will be 10 plus 1. If it is k, next is k plus 1. So if it is k, next is k plus 1. Okay? Then equals to, in place of, if it is k, in place of n, if it is k, we don't write n into n plus 1. What do we write? K into k plus 1. So in place of n, we have written k plus 1. So in place of k, we will write now k plus 1. Again in place of k, we will write k plus 1 plus 1 by 2. I hope you understand. K means k into k plus 1. In place of k, we have written now k plus 1. So in place of k, k plus 1. Again in place of k, k plus 1. So this is what we have got. I hope you understand. That's just only important how to write. Now, for n equals to 1, we have done LHS, RHS. For Sk, we have just taken assume. We have assumed that this is also true. But now we have to prove Sk plus 1 is also true for n equals to k plus 1. We have to prove. To prove that this equals to this. LHS equals to RHS. We have to prove is also true for n equals to k. To prove that Sk plus 1 is also true. Okay, whatever k plus 1 we have written, we will read this way. To prove that Sk plus 1 is also true for n equals to k plus 1. For n plus 1, it is true. For k, we have assumed. For k plus 1, we have to prove. That is what we have to do in each and every sum in this chapter. For this exercise 3.1, whatever mathematical induction we will get, so we will have to do this way. First, this part we have to write. Second, this part you have to write. Third part you have to write. Here, proof is required now. LHS. This is LHS and this is RHS. Let us calculate. Calculate that by doing LHS, whether we can get RHS or not. By doing the calculation in LHS, can we get RHS? Let us see. Okay. Now, let me write LHS. Just I have written LHS, whatever there. So 1 to k is equal to k into k plus 1 by 2. K into k plus 1 by 2. 1 to k, what? 1 to k, how much? 1 to k equals to how much? K into k plus 2. So in place of 1 to k, 1 plus 2 plus 3 plus till k, we can write k into k plus 2 written. Plus k plus 1. Plus k plus 1. I hope you understood. This is what we have to do in each and every sum. Because here to here you will get in k. Okay, one more you will get, then you will understand. 2 k plus 1 plus 2 k plus 1. LCM taken, fraction. So 2 is LCM, 2 into k plus 1, just I have written. So there is no space, so I am writing like this. So here k plus 1, we can take k plus 1 common. Then what is left? K plus 2. K plus 2 by 2. This one we will write now. K plus 1. K plus 2 we will write k plus 1 plus 1. Because in right hand side k plus 1 plus 1 is there. So k plus 1 plus 1 equals to RHS we have got. This is what you have to do. So this is very easy actually. There is nothing, no calculations are there. Only to write the things properly. This one if we do, then we will understand. 1 by 1.2, 1 by 2 into 3, it is not point. 1 by 3 into 4, 1 by n into n plus 1 equals to n by n plus 1. This is left hand side, this is right hand side. 1 into 2, 2 into 3, 3 into 4, n into n plus 1, 3 into 3 plus 1, 2 into 2 plus 1, 1 into 1 plus 1, So this is first term, S1. So let, so what we have to write always, let Sn is equal to whatever there we have to write. 1 by 1.1 into 2, 2 into 3, 3 into 4, 1 by n into n plus 1 equals to n by n plus 1. Now first for n equals to 1. 1 means this one. So LHS 1 by 1.1 into 2 calculation. 1 into 2 is 2. So 1 by 2. LHS we have got 1 by 2. Let us see RHS how much we get. Here RHS after equation RHS n means 1. 1 by 1 plus 1. So 1 by 2. LHS is 1 by 2. RHS is 1 by 2 for n equals to 1. So LHS 1, RHS equal, therefore S1 is true, sorry, Sn is true for n equals 1. This work is finished. I have told you now already, n equals to k, n equals to k, sorry, n equals to 1, k, n equals to k plus 1. These things, these three we have to do. N equals to 1, finished. Now we will go to nk. For nk, just we will write assume. Let us assume sk is equal to 1 by 1.2, 1 by 2 into 3, 1 by 3 into 4 plus 1 by n, sorry, k into k plus 1 equals to k by k plus 1. Just in place of nk, be true for n equals to k. This is what always you have to write for k, which we assume. So nk is n equals to k, work is done. We will go to sk plus 1 now. Sk we have got. Sk means this equals to this. Only in place of n you have to write k, nothing else. Now what we have to write? To prove that s k plus 1 equals to 1 by 1 into 2, 1 by 2 into 3, 1 by k into 1 by k into k plus 1 plus 1 by k plus 1 into k plus 1 plus 1. I think it is correct. Yes. Equals to n by n plus 1, k by k plus 1. Now in place of n, what? K plus 1. In place of n, k plus 1. In place of n, k plus 1, again plus 1. This is n. This is n. This is n. N plus 1. N plus 1. As k plus 1. So in place of n, k plus 1 is written. This one I hope you understand. So last term will be 1 by what? See. Last term is 1 by n into n plus 1. When Sn is there. If S3, we will write 1 by 3 into 3 plus 1. If Sk, then k by k plus 1. Here 1 by k into k plus 1. If it is Sk plus 1, then last term will be 1 by k plus 1. In place of n, again k plus 1 plus 1. This will be last term. I hope you understand. This is previous term. This is last term. Like 1 to 5 and 1 to 6. This is 5. This is 5 plus 1. So if in place of 6, if I write 5 plus 1, so previous will be 5 only enough. So in place of 5, if I write k plus 1, so this is k next will be k plus 1. So k next will be k plus 1. I hope you understand. Okay. Now, left hand side. Left hand side. 1 by 1 into 2, 1 by 2 into 3, dot dot dot, 1 by, actually there is no space, let me write little below. Here, LHS is equal to 1 by 1 into 2, 1 by 2 into 3, dot dot dot, plus 1 by k into k plus 1, plus 1 by k plus 1 into k plus 1 plus 1. Left hand side I have written, and by doing the calculation in left hand side we have to get right hand side. That is what to prove. Now here to here, what can be written? Look here. Here to here equals to how much? K by k plus 1. 1 by 1 into 2 plus 1 by 2 into 3 dot 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 plus 1 by k into k plus 1 plus 1 by k into k plus 1. How much? K by k plus 1. Just putting the value, nothing else. Plus this one we will do calculation 1 by k plus 1 into k plus 2. K plus 1 plus 1, 2. We will do, take LCM now. K plus 1 into k plus 2. So here k into k plus 2 plus 1, here k plus 1. I hope you understand LCM how to take. Now k square 2k plus k plus 1, k plus 1, k plus 2. Next calculation. Calculation is going on. So here k square plus 2k, 3k, k square plus 3k plus 1, k square plus 3k plus 1, k square plus 3k, how it is? Something there is wrong. What is wrong? Yes. Yes, this is wrong. This should be only 1. Okay, sorry. This is only 1. This is only 1. Some calculation is wrong. Okay, wait for it. Okay. Now k square plus k into 2, 2k plus 1, k plus 1 into k plus 2 equals to k square plus 2k plus 1. You can understand this one. K square plus 2 into k into 1 plus 1 square, a plus b whole square. K plus 1 whole square, k plus 1 into k plus 2. 1, 1 cancel. Now here only k plus 1 is left. Below only k plus 2 is left. Or we can write k plus 1 by k plus 1 plus 1. K plus 1 by k plus 1 plus 1, right hand side. Same now. Here little calculation was mistaken, so it was little confusion. I hope you understand. Only you just pause the video, you can get it. Exercise 3, example 3.2.3. 1.2 plus 1 into 2 plus 2 into 3 plus 3 into 4 plus dot 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 plus n into n plus 1 equals to n into n plus 1 into n plus 2 by 3. So let Sn. Here there is nothing to think. Directly rather than 1 into 2, 2 into 3, 3 into 4. Same thing you will have to write again. N into n plus 1 equals to n into n plus 1 into n plus 2 by 3. Just Sn let you have to write. Now for n equals to 1. So LHS equals to 1 into 2. First term. 1 into 2 is 2. So right hand side, this one. N equals to 1. So in place of n we will put 1. 1 into 1 plus 1, 1 plus 2 by 3. So 1 into 2 into 3 by 3. So 3 cancel. What is that? 2. So LH is 2, RH is 2. So therefore Sn is true for n equals to 1. That is finished. Now Sk, let us assume here I am there, okay? Sk, that is what? 1 into 2, 2 into 3, 3 into 4 plus n into n plus, sorry, Sk now. If it is Sn, n into n plus 1. If it is Sk, k into k plus 1 equals to n into n plus 1, n plus 2. So k into k plus 1, k plus 2 by 3 be true for s equals to k. This is what we have to write. Now let me write here only to prove. What to prove? That s k plus 1, that is, what is s k plus 1? S k plus 1 means first term let us write as it is, second time write as it is, 3 into 4 plus k into k plus 1. This is up to k terms, but it is k plus 1. So next will be till k terms k into k plus 1, till 7 terms 7 into 7 plus 1, till x terms x into x plus 1, till k plus 1 term k plus 1 into k plus 1 plus 1, in place of k, k plus 1, in place of k, k plus 1 equals to, let me write here because there will be no space because something to do more, equals to k will be k plus 1, correct? K plus 1. Again bracket k will be k plus 1. Again plus 1. K plus 1 plus 2. Plus 2 by 3. This is left hand side and this is right hand side. We have to prove now. To prove that is true for for n equals to k plus 1. N equals to 1 proved, n equals to k assumed, n equals to k plus 1 we will prove now. Left hand side. Let's write left hand side. Left hand side. 1 into 2, 2 into 3, 3 into 4 plus k into k plus 1, I think, yes. Then k plus 1 into k plus 1 plus 1 equals to 3, sorry, left hand side. Right hand side no need to write. Right hand side we don't have to write. We will prove by doing calculation right hand side equal. So here to here we can write, here to here we can write k into k plus 1, k plus 2 by 3. K into k plus 1 into k plus 2 by 3 plus this one as it is, k plus 1 into k plus 2. 1 plus 1 is 2. Now LCM 3 k plus 1 k plus 2 plus 3 k plus 1 k plus 2. Now k plus 1 k plus 2, k plus 1 k plus 2 we can take common. Okay, this one, this one, this one, this one directly. What is left here? K. What is left here? 3 by 3. Now we will look at right hand side. What is there in right hand side? First right hand side k plus 1. So there is k plus 1. Next term is k plus 1 plus 1. Can it be written k plus 1 plus 1? Yes. K plus 1 plus 1. We can write. Next k plus 1 plus 2. Yes, we can write this one also. K plus 1 plus 2 by 3 equals to right hand side. So as k plus 1 is true for n equals to k. So n equals to k plus 1. Therefore, what is to prove? Establish the result by using mathematical induction. Yes, Sn is true for n belongs to natural number. N means any number, any natural number will be true for Sn. Sn is true for n, Sk is true for k, Sk plus 1 is true for k plus 1, Sx is for x, so anything. So this is what you have to write always at last. Always at last. This is the conclusion of this sum. Example 3.2.5. N belongs to n given. N is greater than or equal to 4 given. To show that factorial n is greater than n square. Factorial n is greater than n square. Now I hope you know about factorial. About factorial you have heard and you have got in lower classes. Factorial. So let me explain, let me recall factorial n. Factorial n, let me recall. Factorial 5. Factorial 5 means, I know 5 into 4 into 3 into 2 into 1. This is meaning of factorial 5. Factorial 3. 3 into 2 into 1. That means we have to go on multiplying with decreasing order. Decreasing. Factorial 6. 6 into 5 into 4 into 3 into 2 into 1. Till 1 we have to multiply, which we write shortly, that is called factorial. That is called factorial. I hope you understand this factorial. Now here what is to prove? Condition is given that n is natural number, that is compulsory condition. This is compulsory condition. This is given n is greater than or equal to 4. N is equal to 4 and n is also greater than 4. This is the condition given to show that factorial n is greater than n square. Same formula, same steps we will apply here. First, let s n equals to factorial n greater than n square. Same process is same. So for n equals to 1, here left hand side, right hand side equal we cannot prove, but we have to prove left hand side is greater than right hand side. So let us see what calculation we get from left hand side. Sorry. For n equals to 1, factorial 1 we will write. Factorial 1 is 1 only. After 1, no more numbers. Right hand side. Right hand side n square. So what is square? 1 square is 1 only. N equals to 1. So 1 square 1. So LHS RHS equal. Therefore S n is true for n equals to 1. That is finished. Next, K. Let us assume Sk. What is Sk? Now we will write factorial k is greater than k square. Be true for n equals to k. Now we will go to k plus 1. We will go to k plus 1. Now what we see here, that n is greater than 4. Sorry, so n equals to 1 is something is wrong here. LHS is okay. Wait. This is what? Let me rub. Okay, something is wrong here. I have done a mistake. So let us do. LHS is equal to factorial n equals to 1. RHS equals to 1 square. So LHS is greater than RHS, which is not correct. Here greater than is there. So for n equals to 1, for n equals to 2, for n equals to 3, we will not get because n is equal to 4 and n is greater than 4. So for n equals to 4 we will do. I hope you understand. Because condition is given n equals to 4 and n equals to 5. So n greater than 4. But we cannot use 3. We cannot use 2, 1 like that. According to this condition, we will use for n equals to 4. Now we will do LHS and RHS. Let us see whether LHS is greater than RHS or not. Let us see now. LHS factorial 4. Factorial n factorial 4. 4 into 3 into 2 into 1. 4 to the 12 to the 24. RHS n square means 4 square, that is 16. LHS is 24. RHS is 16. That means 24 is greater than 16. So LHS is greater than RHS. Now we can write Sn is true for n equals to 1. Now we can write. So n is equals to 4. When n equals to 4, then only LHS is greater than RHS. LHS is greater than RHS. Now we will write assume. Let us assume Sk. What is Sk? Factorial k is greater than k square. Be true for n equals to k. This is assume. Now to prove as k plus 1 factorial k plus 1 greater than k plus 1 square. I hope you understand. In place of n k plus 1. So n k plus 1 and k plus 1 square is in its place. Now we have to calculate left hand side. Now we will do left hand side. Little critical here. Left hand side is k plus 1 factorial. This k plus 1 factorial we can write this we can write k in place of factorial k plus 1 we can write k plus 1 into factorial k. K plus 1 into factorial k. I will show the example. In place of factorial 6, what can be written? Look here. Factorial 6 is equal to 6 into 5 factorial. Because 5, 4, 3, 2, 1 is a factorial. Let me show you one more example. Factorial 7. 7, 6, 5, 4, 3, 2, 1. So factorial 7 we can write this way also. 7 into factorial 6. This is what I have written. This one just think as 7. 7 is as it is 7. Next will be less than 7. K plus 1, it's less than 1 will be k. Look here. 7 and 6. Difference is 7 minus 1. Now in place of 7, if I write p, then p minus 1. In place of 7, if I write k plus 1, then in place of 7, k plus 1 minus 1. So k. 7 means think as k plus 1. 7 means k plus 1 minus 1 minus 1. I hope you understand. K plus 1 is itself 7. So this one and this one as it is. 7, 7 as it is. Next term will be 6. That means with 7 we will subtract 1. What is 7 here? K plus 1. Minus 1 will be minus 1 plus 1 cancel. Here it is K. So this is greater than 4 plus 1 K square. Look here. Why written 4? Because n is equal to 4 or n is greater than 4. So this number is 4. In place of K, 4 written. 4 plus 1. So K plus 1. K. This one. Factorial K is greater than K square. Factorial K is greater than K square. So K plus 1 is greater than 4 plus 1. K plus 1, 4 plus 1. Factorial K square. Greater than sign, we cannot put equal sign because in K, greater sign is there. In K, greater sign is there. Okay. Now what can be written? Now we can write, let us write K plus 1 factorial K 4K square plus K square. 4K square plus K square. 4K square plus K square. This, wait, factorial K plus 1 is greater than 4K square. 4K square. Okay. Now look here. If factorial K plus 1, we can write K plus 1 into factorial K. Then K plus 1 into factorial K. Again we can write K plus 1 factorial. K plus 1 factorial K plus 1, we can write K plus 1 into factorial K. K plus 1 into factorial K, again we can write K plus 1, same, meaning is same. But here I have written only 4K square, this one is neglected. Why neglected? Look here. 7 plus 2 is greater than 4 plus 3. 7 plus 2 is greater than 4 plus 3. 7 plus 2 is greater than 4. 7 plus 2 is greater than 3. So next line we can write 7 plus 2 is greater than 4. If we don't write 3, meaning will be same. Greater only, no? 7 plus, sorry, not 4 plus 2. Okay, 7 plus 2 is 9. Okay, 4 plus 3, no problem. 7 plus 2 is 9, 4 plus 3 is 7. So 9 is greater than 7. 7 plus 2 is greater than 4. 7 plus 2 is greater than 3. 7 plus 2 is greater than 4 plus 3. Anything can be written. If we write 7 plus 2 greater than 4, then also it will be true. Because this is always 9 only, no? Whether you write 4 or anyhow, it is greater. So this is why this is neglected. This is not needed. Greater, smaller, these things are whenever we get, we can neglect these things. Now K plus 1. This one we can write 2K whole square. Again K plus 1 greater than K plus K whole square. 2K means K plus K. Now what to prove actually? Factorial K plus 1 is greater than K plus 1 whole square. But we have got K plus K whole square. The same thing here, this K can be neglected. I will show you how can it be neglected. Because greater sign you can neglect. K greater sign K plus 1 whole square. Look here, how can we prove it? Here 1K is neglected, in place of K 1 is written. Let us see it is correct or not. What I have shown, factorial K plus 1 is greater than K plus K whole square. Let us see, this is 3. Suppose K is 3, suppose 3 plus 1 is greater than 3 plus 3, 6 square. 3 plus 3 is 6 square. 6 square is 36. This is only 4. 4 into 3 into 2 into 1. Factorial 4 means 4 into 3 into 2. 4 is a 12, 12 is a 24. This side 24 and this side 36 cannot be done. 24 is smaller than 36. So if we write 3 plus 3, we cannot do that. If it is 3 plus 1, then only it will be correct. 3 plus 1 is 4, 4 square is 16. Then 24 is greater than 16. That is why in place of K 1 is taken. That is what we have to understand. This is hence proved. Factorial k plus 1 is greater than k plus 1 whole square. This is what example. Please repeat, please revise, then you will understand. One more example is left, I think. Example number 3.2.4. Example number 3.2.4. Yes, this is not done. 3.2.4. What is written? A plus AR square plus ARN is equal to AR to the power n minus 1 by R minus 1. This is what given in exercise example number 3.2.4. So let first thing, as n is equal to A plus AR square equals to plus ARN equals to AR to the power n minus 1 by R minus 1. For n equals to 1. Same, process is same. So S1 is equal to A or A plus 1. Look here. A plus AR will be the first term. Why first term A plus AR? In previous all the examples we have taken first term is S n equals to 1. In the calculation we have done in first term only. But here we are taking A plus AR both. Why? A plus AR plus AR square. How can we write AR0, AR1, AR2? So this is what we will write. So here AR to the power 0, AR to the power 1. Okay, this one here, this one here. So this one we cannot take as first term because R equal to 0. 0 is not natural number. So as a whole, this one is taken as first term. So A plus AR is written because of this 0. Because here R is not there, that means. So you will have to start from R, no? R1, R2. Continuity is there. I have told you already. In the first page, I have told you continuity must be there. If it is 1 cube, 2 cube, 3 cube, 4 cube. So cube, cube, cube. 1, 2, 3, 4. So but here it is not continuity. Starting is not from 1. Sorry, starting is not from 1. So starting is 1. That means here this is where starting is from 1, 2, 3. That is why together it is first term. I hope you understand. This is the meaning, and this is why this is very, very important sum. So in place of okay. So S1 is A plus AR only. Here there is nothing, neither N, nothing. In previous sums what we have done, S for N equals to 1, in place of N we put 1. In place of N we put 1. Okay. In previous sum also. In previous sum, N equals to 1 means here we write that, do the calculation. 1 into 2 is 2. But here what calculation we will do? We cannot do anything calculation. A plus AR we cannot add, we will keep as it is, this one only. That means I am supposed to write left hand side. Left hand side is A plus AR. Now we will go to right hand side. A and AR we cannot add. So A R to the power 1 minus 1 by R minus 1. In place of N, 1. Here there is no N, nothing. So A plus AR cannot add. We will keep as it is, this one only. So this one, let us do the calculation. A R to the power 1 is R only. R to the power n plus 1 was there in the question, no? Question I have written wrong. R n plus 1, n plus 1, 1 plus 1, 2. Okay, I have written the question wrong. So A R square minus 1 square, R by 1, So a r plus 1 r minus 1 by r minus 1 cancel. R square minus 1 square means a square minus b square formula, a plus b into a minus b. This one cancel. A into r, a into 1 a, or we can write a plus ar. Left hand side a plus ar, rs is also a plus ar. So Sn is true for n equals to 1. So I hope you understood. Now let us assume Sk what? A plus ar plus ar square plus ar k. Ar to the power n, so ar to the power k now. So ar to the power k plus 1 minus 1 by r minus 1. Okay, in place of n, k plus 1 as it is. Be true for n equals to k. Now to prove Sk plus 1, here I will write a term a plus ar square plus ar k, r to the power k plus ar k to the r to the power k plus 1 equals to ar to ar k to r to the power n plus 1. N means k plus 1. Plus 1, I hope you understand. R to the power n plus 1. What is n? N is k plus 1. Minus 1 by r minus 1. This is what we have to prove. Left hand side equals to right hand side. Now calculation only. LHS is equal to, this one whole you will write, a plus ar square plus ark plus 1. So in place of this we can write this ark plus 1 minus 1 by r minus 1 plus ark plus 1. Ark plus 1. Now you will take LCM. R minus 1, r to the power k plus 1 minus 1 plus ar k plus 1, okay, into r minus 1. So this calculation we will do in the next page. What we have got? ar to the power k plus 1 minus 1 plus ark plus 1 into r minus 1. This is what we have got, I think. Yes, by r minus 1. So we will do the calculation. Ark plus 1 multiply a into minus 1 ark plus 1 into r multiplying minus ark plus 1 ark plus 1 minus ark plus 1 cancel. Now what is right hand side? Let us see. R to the power k plus 1 plus 1 r to the power k plus 1 minus 1 by r minus 1. This is right hand side. This is what we have to get. Remember that. So ark plus 1 into r. Let us write first this minus a here. Now let us take a common from these two terms. After taking common, what is that? R to the power k plus 1 into r. A to the power 3 into a to the power 4. What you write? A to the power 3 plus 4. Power will be added, no? So r to the power something, r to the power 1. So r to the power k plus 1 minus 1. A taken common equals to right hand side. This is what we have got. So till this much examples finished. So what we have understood, remember that here we can write at last, therefore Sn is true for n equals to k plus 1. Therefore Sn is true for n belongs to any natural number. N is k, n is, we have proved n is 1, n is k, and n is k plus 1. That is what we have to prove in each and every sum of exercise 3.1. So till then it is finished. So in the next video we will do the exercise 3.1.